Rationalizing one-term denominators. Let's just start by looking at these two numbers, 1 over the square root of 2 and 3 root 5 over 4. Don't ask me why, but mathematicians hate irrational denominators, and they always have. They do not like it when there's an irrational number in the denominator, like the square root of 2. But it's totally okay if it's in the numerator. I tried to do some searching for why this is, and the best reason I could find is that it's historical, which is that before the existence of a calculator, it's a terrible process to divide something by an irrational number. Like dividing by the square root of 2 is just no good without a calculator. But dividing by something, even an irrational number, like dividing the square root of 5 by a number like 4 is okay. There's a process for doing that. But whatever the reason, and it's historical, it's just one of those things that's now standard in math. It's going to be expected here in this course, and it's going to be expected at every level beyond as you go into future math courses. So we always want your answers to have rational denominators. So what we're going to be doing is called rationalizing the denominator. So it's a process where we use multiplication by 1, that's something we've talked about before, to turn a fraction with an irrational denominator into an equivalent fraction with a rational one. So if you end up doing a calculation or problem and you get an answer with an irrational denominator, that doesn't mean it's a bad answer. It just means that we will have a way to rewrite it without an irrational denominator. So for example, 1 over the square root of 2. We need to ask ourselves, what do we need to multiply? What do we need to multiply the square root of 2 by so that we get rid of the radical? That's what I want you to focus on. What would I have to multiply by? The answer is that we have to multiply by the square root of 2. So we're going to use this property of 1, multiplication by 1, which means we're going to multiply the bottom by the square root of 2, because the square root of 2 times the square root of 2 is 2. And I'm going to draw your attention to that. The square root of 2 times the square root of 2 is the same as the square root of 2 squared, which is 2. So multiplying the square root of 2 by the square root of 2 gets rid of the radical sign. So we're going to multiply both the top and bottom of this fraction by the square root of 2. So we're using that property of 1 that we talked about earlier. And when we do that, we're going to get 1 times the square root of 2, which is just the square root of 2, over the square root of 2 times the square root of 2, which we just showed, is equal to 2. So 1 over the square root of 2 is equivalent to the square root of 2 over 2. So this is what we call rationalizing the denominator. And this is the way we want our final answers in this class to look. So here's our general strategy. To rationalize the denominator of a fraction, first simplify the fraction as much as possible. It's going to make our lives easier. Then multiply by the top and bottom by the simplest radical in the denominator. So our first example has no simplification that's necessary. So we're just going to go to that second step, multiply the top and bottom by the simplest radical in the denominator. That would be multiplying by the square root of 3. When we do this, we're going to get 4 times the square root of 3 on the top, and in the bottom we have the square root of 3 times the square root of 3, and this is equal to 3. And we can show this any way that makes sense to you. You could either say, well, the square root of 3 times the square root of 3 is the square root of 3 squared, which is 3. Or you could say the square root of 3 times the square root of 3 is equal to the square root of 9, which is equal to 3. Whatever way makes the most sense for you. But ultimately, when you multiply the square root of 3 times the square root of 3, we're left with just 3. Here's our second example. So we have the square root of 3 over 20. And this is an irrational denominator because I have the square root of 3 over the square root of 20. And the square root of 20 is not a perfect square, which means that it's irrational. But it can be simplified a bit. So we're going to start there. We're going to multiply, or write, I should say, we're going to write the square root of 20 as 4 times 5, square root of 4 times 5, so that we can see that there's a simplification in there. So that's the square root of 3 over the square root of 4 is 2, and left over is the square root of 5. So now we're going to multiply by top and bottom by something to get rid of the square root in the bottom. And as I said in the instructions on the last slide, multiply by the simplest radical in the denominator. So don't worry about the 2. All we have to multiply by is the square root of 5 on the top and bottom. On the top, we have the square root of 3 times 5 is the square root of 15. And on the bottom, we have 2 times the square root of 5 times the square root of 5 is just 5. So I have the square root of 15 over 10. So I've rationalized the denominator for my fraction. Next up, I want to show you an example with a variable. Really just to draw your attention to the fact that it doesn't make a big difference to our strategy. In fact, it doesn't make any difference to our strategy. We're going to multiply by the simplest radical in the denominator. And in this case, the denominator cannot be simplified. So we're going to multiply by the square root of 6x on top and bottom. Again, this is that property of 1, so that multiplying by 1 doesn't change the nature of the number, it just changes how it looks. So in the top of the fraction, I have 3 times the square root of 6x. There's no simplifying that we can do there. And in the bottom, I have the square root of 6x times the square root of 6x, which is just 6x. Now there's a bit of simplification I can do now because I have 3 over 6 and each can be divided by 3. So 3 divided by 3 is 1. So I have 1 6x, or I'll just write it as square root of 6x. Sorry, 3 divided by 3 is 1, so I have just left over 1 square root of 6x. And then in the denominator, 6 divided by 3 is 2. So I have 2x. And now my denominator is rational. Well, it has a variable of x, and x isn't any number. It's not rational or irrational number. It's just a variable. But for the purposes of what we're talking about, basically getting rid of the roots in the denominator is our goal. So if there's a variable left over there, that's fine. If x happened to be the square root of 2, well, then we'd have a problem because it would be an irrational number again. But as far as the variable is concerned, we're just trying to get the radical sign out of the denominator. And then the final example I want to talk about, we've so far been dealing with just square roots, but we can use the same principle to get rid of cubed roots, only it's a little bit different because multiplying top and bottom by the cubed root of 6 over the cubed root of 6, well, that actually doesn't cancel the radicals because the cubed root of 6 times the cubed root of 6 is equal to the cubed root of 36. And the cubed root of 36, well, 36 isn't a perfect cube, it's a perfect square. So I actually need to multiply this by another cubed root of 6. And if I do that, multiply by another cubed root of 6, so that would be 3 cubed roots of 6 would be 6 times 6 times 6 is 216. And 216 does have a perfect cube, or a perfect cubed root, which is 6. So I actually need to multiply top and bottom of this fraction by the cubed root of 6 twice. The reason being I now have 3 cubed roots of 6 multiplied together. So I have 1 times the cubed root of 6 times the cubed root of 6. So that's, I'm just going to write it as now as cubed root of 6 times the cubed root of 6 in the numerator over, I have 3 cubed roots, so that's like 6 cubed, cubed root of 6 cubed is just 6. So I actually had to multiply the numerator and denominator by the cubed root twice in order to get rid of the cubed root. And I'll just simplify this, 36 over 6. We're not going to see a lot of this, but it's just an interesting look at what we're doing when we're rationalizing the denominator. It's not just as simple as multiplying by, top and bottom by your root that's in the denominator. You really have to think about why it is that you're doing it. And you're doing it to get rid of the root. So in the cubed root case, you have to be really creative with how you get rid of that radical in the bottom.